Bailey. Chelsea Bailey. Sorry. Come on. Okay. All right. So that is, but that would either be right here or right here that it says, where's F increasing on, and they tell you to define that. Okay. Where is F prime negative? Bailey said it was positive there and there. All right. Where's it negative? Negative 3 to 5. Good job. Now, again, if you have to estimate it and it was like negative 2.8, then you start with negative 2.8 here. Don't say, oh, I think it might be 2.7. Well, it's the same point here as here. So just make sure those match. Good, Maria. Okay. So this is your below the x-axis, which is negative. Okay. All right. Now, again, we're looking at F prime. So we want to know where F is concave upward. Okay. What's going on with, what do we know about concave up? What's the theory that goes with that? Concave up.
F double prime is positive.
Very good. F double prime is positive, and concave down would be F double prime is negative. Good job, Chelsea. Okay. Now, I'm going to, this is for increasing, I'm just going to, okay, so this is F double prime here. All right, how do I tell what F double prime is doing on F prime? It's supposed to be, what's the relationship between F prime and F double prime? Sorry, that's a bad question. Isn't the relationship between F prime and F double prime the same as between F prime and F? Okay, so what are we looking at for F prime instead of F double prime? What are we looking at for F? Yes. So F prime would be increasing and F double prime would be decreasing. Okay? Go backwards, make sure that makes sense. F prime is increasing, F double prime is positive. It's the same relationship as we had right here, except we were doing a different derivative. Okay, so you've got to get it all straight. All right, so we're back to increasing and decreasing. All right, so it's not going to be here and here, split. All right. Increasing. Does it start out increasing or decreasing? F prime. Decreasing. Because if you think this is, you think about tangent lines, if you want to do that, those are all negative. Until we get to what? 0. Good. So a decreasing, which would be concave down, would be to 0. So that's all concave down. Then we would start increasing to about right there. Okay, went a little bit far. So 0 to where's the top of that piece? Because when it flattens out, that's not increasing or decreasing. The derivative is 0. So where would you guess that to be? Brits? 7.5. 1, 2, 3, 4, 5, 6, 7. Yes, I would say that would be pretty close. Okay, and then what are we doing again? Right here, we're decreasing again, right? So at 7.5 to infinity. Okay, this is concave up, just to be clear. Okay, and this is concave down. Okay, so you've got to really focus on increasing, decreasing, or positive or negative. I want to, when you're done, I want to go back and just show you where I said that in my notes here, in your notes. Any questions before I go back? Yes.
I'm confused. I'm gonna get how we just did it, but like what? When you Like,
Okay.
the
So,
relationship between like
well, f prime, okay, whenever you have a function and you want it increasing or decreasing, its derivative is positive or negative, okay? So if you want increasing and decreasing here, you want the same relationship between its derivative, which is positive or negative. So far, so good?
yeah, I get that.
Okay, so what we had to do is we had to back all the way up to concave upward because, remember, we wanted positive for concave up for f double prime. Well, that means to back up, we need f prime to be increasing. And then f double prime to be down, we need f double prime to be negative, so we had to back up and say, well, then that makes f prime decreasing. It's the backwards order because usually we start here, we go here. Like we started here, increasing, and we went here. But this is, the red is that, derivative is that. So we're just going in the opposite order. Okay, anybody else? Go ahead.
If they give us the graph of f double prime, we not need to do that.
Correct. Correct. Usually they're not going to give you one, both. They're going to give you one or the other. Okay. Let's see. I just want to point out over here when we're doing the f prime increase at f double prime is greater than 0. Okay. Now I have you memorize this theory. This theory is kind of it's hard to remember. It's easy to get mixed up, but if you just remember the relationship between f and the function and its derivative, you should be good. All right, but it is there. All right, at what values of x does f have an inflection point? Okay, here's the concavity. We started, I'm just going to write a little number line. We started with concave down. At 0, we switched to concave up. At 7.5, we switched again to, wait. Yeah, that's right. And at 7.5, we switched again to concave down. So if we write all this out on the number line, where are the inflection points? Inflection points at x equals 0 and 7.5. Okay, now that's where the concavity changed from up to down or down to up. It's the same idea as the local backs and ends, except we're looking at f double prime instead of f prime. Okay, now we don't have f of x, so we cannot find the inflection points y value because we don't have f of x. But we can do it second semester, but we can't do it first semester because we don't know how to go backwards from f prime values to f. Okay, so that's all we can do is write the x values. Don't just put 0, put x equals 0 in that way it's real clear. Okay, let's try to sketch a graph of f, shall we? This is the fun piece, right? All right, we know we have to be f, let's see what f is doing. F is increasing, we're going to write it all out again. At negative infinity to negative 3, and then again at 5 to infinity, so you're going to split there. Decreasing from negative 3 to 5, concave up, 0 to, actually I'm going to start with concave down because that's at that other end. Negative infinity to 0, and then again at 7.5. And then concave up in between there. Okay. So you are going to graph a function that does all that. Okay, so we'll need to put negative 3 on there. You'll need to put 5 and 7.5. Okay, anything else? 0. Those are where you're going to split. To the light side, going around, you're going to see what you can come up with. You don't really have any tall, F values, so it's just the shape that's going to be changing. That I'm going to be looking at. Give you a minute. Stuck, Sarah Stewart, or you're just screen just the right. Like, there. So you can check your decreasing, increasing, concave up, concave down. They're looking pretty good, really. You're all are looking like it should, so that's good news. Let's see. Check before I start talking how you're. Looks good. Good. You're going to concave down and increase it kind of sideways thing. Concave down and increasing could be like this. So you're still going up here. Stuff in there. All right. Concavity, doesn't have to be straight up and down like you think. Let's take a look at some of yours. Let's see. All right. As you will notice, we got these. Let's take a look at where he is. I'm not sure. Okay. This is where he is. All right, let's see if everything matches up here. All right. So, increasing definitely. If you have increasing and then decreasing, what should be at x equals -3? A max. Does everybody have a max at -3? Okay, and you should also have a min where? At 5. Okay. Now your min, hers is sitting on the x-axis, but I noticed there were other people's here. Let's see. That went down. I don't know whose that is. Bailey. Let's check out Bailey's. Oh, look, she's already got it marked. Bailey, so good. Not that Maria's fat. All right, let's see. So the max and the min, you really don't know how far down they're going to be. All right, so the max and the min, the increasing, the decreasing, increasing, decreasing, increasing, increasing, decreasing, increasing. Okay, now concavity. From 0 to negative infinity should be a concave down. So, like right here, I would say that would be concave down. From 0 to 7.5, which would be, is that right? 0 to 7.5. That should be, okay, so.
Yeah, that's fine.
That looks good. Okay, it's concave up. Okay, 7.5 is what? Right here. That's reasonable. Okay, and then the concave up again. No. Down again at 7.5. So this was weird. It's supposed to be also increasing, so it can't go like that. So I think we didn't really know what to do with it after this. Okay, this is pretty straight. You want it to be concave down and increasing. Okay, that kind of just like leaves me hanging. Let's see if we have another one here that did that. Let's see. I'm not looking at names. Again, we just kind of stopped. You got to go past 1.5. Maybe that one. Let's see. See what kind of small. Okay, so after 7.5, it's again kind of flat. Let's see what Karina's got here. So right here we stopped with the, I just wrote it here. Yeah, it's supposed to. But it's definitely increasing. It doesn't just stop, which we don't want it to stop. But that was the issue, and then possibly this could be turning down, right? So I would say that one probably is the best at that end. Okay. All right. Let me look at. Good job, Tim. Thank you for sharing. I know you. Oh, okay. Let me show you what the computer-generated one looks like, and you'll be impressed with yourself. That's what it really looks like when you get out of here.
Wait, but that's decreasing. Oh, I'm looking at the wrong one.
Yeah. The old one was your derivative. The other one, now there's no way you could get those values, you know, like the right max and the right min unless you had an equation. So don't worry about that. But the shape is what you are doing, okay? So you all were pretty close. It's the same shape. Look at this. Try not to look at where it is. It's the same shape, okay? So you did good. Or well, I should say, right? Okay, let's try another one. Sketching. All right. Now we have some things, and what I usually do on a test is I'll say, I've got all these criteria. You pick out the graph that best fits the criteria. Just because I don't really, I'm being honest here, I don't really want to look at, okay, yeah, that works, that works, that works. I want to say that's the only one that works out of those 4, 5, 6 that I give you. Okay? So let's figure out what they're telling us here. Okay, f prime is greater than 0 on negative infinity to 1. What does that mean? What do we know about f? It's increasing. Good. Increasing on negative infinity to 1. Okay? I like to start at the negative end. It just makes sense in my brain to me to start at that end because that's where I usually start graphing. Okay. F prime is less than 0. So what does that mean about F? It's decreasing. Okay. What else do we know with that information? Tell me what else we know. There.
Is it will be the increase will be about 0 again?
Not necessarily.
Oh.
I could be down here increasing and then decreasing. What else do we know?
It has a maximum limit.
That's it. Good job. Okay. There's a max at x equals 1. That's where it turns from increasing to decreasing. That automatically makes a max. Okay? All right. Then we go with f double prime. If f double prime is greater than 0, what do we know about f? Concave up. Okay, concave up on that left end, and then at the right end. In between, I assume it's going to be concave down. All right, on -2, 2. Okay, and what does that give us? It's the concavity changed twice, I think, didn't it? What does it give us on the graph? Inflection points, good. Inflection points at x equals, we went from up to down at -2, and we switched again at 2, didn't we? From down to up. Okay. Those aren't like super, like, here's where you turn, but it is kind of nice to have points where we're going to figure out something's happening. Okay? All right, and then we get some limits. Okay. This is a negative infinity, is it? It's disappearing on me. Yes. Okay. Sorry. I don't know why that does that. Okay. So on the limit as x approaches negative infinity at this negative end of f of x, we're getting to -2. What does that give us? What does that give us? It is. Go, Karina.
Yeah.
Horizontal asymptote at the negative end at -2. So I'm going to go ahead and draw that in here. Okay, and this is an unusual function because at the other end, we have a different horizontal asymptote of y equals 0. It's a piecewise, clearly. Okay, so we have, let's do it this end, we go this way. Okay? Change it. I didn't. I'm just wanting it at this end and at this end. I do not know where it changes. Good question, though. Yes, I implied I knew that, and I did not know that. I just want to do it at that end, and I don't have much of an end because I only got 5. So, all right, so I'm going to check 1. Something's happening. -2. I'm not marking ordered pairs, mind you. 2. And, okay, go for it. Graph away. Let me give this back to you so I don't. There's not a really right, but there is a wrong. This for terrain, that's kind of normal. It's a little delayed, clearly. All right, this one, who's that? Karina's. That one looks good too. I know some of you are like, okay, trails off at the -2, trails off at the 0. Horizontal asymptotes work. All right, concave up. So we get to here. So that's up. Then it's down till we get to here. Okay? And then it's up again. All right? The decreasing, increasing till what? 1, decreasing. Perfect. Okay? That is good. And here's a thing, and this is, critical thinking in general. Don't try to just stare at it. Just put something up there, and then you're like, okay, well, that doesn't work. Let's fix that. So don't be so, hesitant to just throw something up there and then, paste. Fix it. Because that's how you're going to get it. You're like, wait, that piece doesn't look quite right. But if you're just staring at it blankly, let's see. I think, Sarah, you got yours yet? Yeah. Did it come up? Oh, there, finally. Okay. And it wasn't you, it was the dinos. Slow to respond here. All right, here's Sarah's. It looks very similar. She's got a max at 1. She's got a split here and here. That's your, hello. Ah, that's your concave down and concave up. Yes, it sure is. Okay, anyway, I guess we're done. Okay, so here's are your computers still on?
Yeah, I think it was just an part.
Yeah. Okay, that thing is not sounding right, is it? Okay, I was going to, I have a worksheet that I want you to work on together in some pairs. And I was going to do the first problem if we can get this thing. Sounds really bad. Okay.
Do you need me to press the help?
I think I'm going to leave it. It feels like it's needs some time. Let me just show you, and then you can go to LMS. Yes, Bailey. Just wait. Okay. Let me turn the light on. I'm going to do the first one. The directions say, it's a handout, so one of you all can grab it in your group. All right. Determine the signs of the first and second derivatives for the function. Okay. LMS. That way it's in front of you. It's called, good Lord. That is scary sounding. I think there we go. She cleaned it up. Remember we had all the eraser issues? She took it apart and cleaned it up. Miss Hope Camp. You don't like my pronouns?
What?
Did you say who?
No.
Oh, okay.
I'm just saying that it was good.
Oh, okay. Yeah. She just cleaned up the sensors and it's all good. So, it's called, yes, 2.8 homework, but it's really not homework. We're just going to work on it. We are going to have a quiz Tuesday, which is 2/7, 2/8, and 2/6. So it's just I'm guessing about 30 points in the minor category. All right. What's the matter?
You wanted to know his essay, and my first thought was
Actually, alrighty then. What does F prime say about F? Is what it really says. Yes.
I know what it says.
All right, I know.
I know.
All right, so this is what it looks like right here. Yes, you can do it on paper. Oh, wait, that's the notebook we were. No opening. I didn't open the one. Oh, okay. 2.8. All right. This is what it looks like. The first 6 are done the same way. Okay, so the graphs that you're looking at are f of x. Okay, so we are supposed to be looking at the first and second derivatives, and all we're looking at is signs. This is a word, so Fine. Yeah, I did. Okay. We're just looking at signs as in positive or negative. Okay, so F prime. What do you know about F prime? These are the tangent lines. Let me just draw a few in here. What do you know about them? They're all positive. So what's F prime for the whole works? Positive. And really it only starts at 0 to infinity. Okay? What about F double prime? What are we looking at as far as F goes? We're looking at F. F prime tells us what? Concavity. Is that concave up or concave down? Okay. So that would make F is concave up. So F double prime is okay. So that's what I want to know. I mean, anyway, so you're going to do that. Here's the, okay. Let me put you, it's just kind of a practice of getting used to thinking about something else while you're looking at something else. Okay? All right, so.
Wait, for the quiz, it's on what we did last.
2.7, which is graphing derivatives from the derivatives. 2.6 is derivatives, yes. 2.6, 2.7, 2.8. All right, Lauren and Karina. I'm just randomly putting checks here. Bailey and Sarah. Coffin. Natalie and Rachel. Annalisa and Sarah. Melanie and Maria. And Chelsea and Olivia. Okay, you're working together on this. Sarah, well, I said Sarah Coffin. Oh, wow. And, okay, Sarah Stewart. I don't know, because I didn't mark it. I just randomly checked. So, who was working with the Sarah? All right, Annalisa and Sarah. Because there's got to be three. Threesome. Yes. What do you want to do? Do it. No. We're going to write the answers on paper. We don't need that printed out. Did you just print it?
Well, it didn't actually print. It's print until you go and say okay.
Oh, okay. So you're good. All right. In your groups, pairs, whatever they are, chop.
Yeah.
Walking around, chop. Yeah.
I'm doing it. Can we still move on?
Sure.
All we have to put were like F prime and F like
No break being in the first 6 now. After the first 6, you're doing something different. So. If you have any issues, ladies, if you're confused, please don't. They're confused. Some